This is Unix lab exercise number 4, and in this exercise we're going to see base conversions. Usually changing numerical bases such as converting from base to, that is binary, to base and that is decimal, is known as binary conversions. So here we are going to see 4 types of conversion. Let's see how the shell coding has to be done for all these programs and conversions. So here there is a sample program. So initially the first program is to convert from binary to decimal. So we take the input as a binary digit, that is zeros and ones, and if the binary digit is not equal to 0, then it proceeds to the while loop, and then there we have b number, decimal and powers, which are already initialized. So the values are, again it checks if the value of binary is not equal to 0, and then we have temporary variables like reminder, decimal, power and binary, and then reminder is equal to binary modulus 10, and decimal is equal to decimal plus reminder into power, and power will be power into 2 because it is conversion to decimal. And then we'll get the answer, and finally we'll have to show the output of the answer. And the next one is decimal to binary. So here again we get a input as a decimal number, and then finally if it is not equal to 0, then the following are being proceeded. We have r, b and bin as the temporary variables, where r is equal to by b modulus 2, and then b is equal to b divided by 2, and then bin is again equal to r and bin. Then finally the expression is again divided by 10, and then final answer is being obtained. Then the next program is for hexadecimal to decimal conversion. A hexadecimal value is being taken as input, and then when it is not equal to 0, then the further procedures are being followed. So here hexadecimal hexanum is actually assigned to the value that is being given, and decimal and power is also initialized. So again, when this value is not equal to 0, a reminder, that is expression hexa modulus 10 is the modulus of hexa will become the value for reminder. Then decimal will be decimal plus reminder into power. Power will be equal to power into 16 because it is a hexadecimal number, and hexa will be hexa divided by 10, and then finally we obtain the decimal number. Then the last one is binary to hexadecimal conversion. The binary digit is being given, and then finally using the formula O base and I is equal to I base, and we find the binary equivalent for the hexadecimal equivalent for the binary code. So let's see how the output looks like. So when we run this program, initially we have a binary digit, say 10110, then the equivalent decimal equivalent is 22. Now let's do the reverse of it, and as you can see here we get the input as the same. Now we'll have to give a hexadecimal number. Let's say 16 is the hexadecimal number. So when we enter, decimal value of that is 22. Now let's say the decimal number as 10110. So when we give this as the value, you have, as you can see, it is again 16. So by cross checking these values, we can get to know that the following codes are correct, and the following experiment is done successfully. Thank you.